So the basic idea of this proof is that if we start listing prime numbers from the beginning, so from the smallest prime number and just keep working up, then however many places we get along this list, if we multiply all the entries together and add 1, this new number will be divisible by at least one new prime number. Because of that, no matter how many prime numbers we list, it will always be possible to generate a number that implies the existence of a new prime number. At least one new prime number, perhaps even more. Because of this, no matter how many prime numbers we put into a list, there's always going to exist more prime numbers. So the reason why this works is that for a number to be a multiple of another number, it has to be different from the previous multiple of that number by that number. So for example, if we have 2 plus 2 plus 2, that equals 6. The numbers nearest to 6 that are also divisible by 2 are 4 and 8, and it's because they're 2 different from 2. Now, if in constructing this number, this new number, out of our list of primes, we multiply these together and then we add 1, then obviously none of these factors are 1 different from this new number that's comprised of multiplying all these numbers together and then adding 1. Now, if we couple this fact with the knowledge that all numbers are divisible into primes, then that means that this whole new number that we've just made is going to have to be divisible by prime numbers that aren't any of these prime numbers. So because of that, for any list of prime numbers that we write out, we're always going to be able to very easily make a new number that isn't divisible by any of the prime numbers on that list. So for any list of prime numbers we write out, there must necessarily be prime numbers that are not featured on that list. So there's no way to list out every single prime number. There's no point at which this list of prime numbers ends. Prime numbers are infinite.